Hello students, let's play a number game. Look at the picture and tell me how many trees there are between the first and the last tree. Simple. 3. Okay, now tell me how many students are there between the first and the last student. This was also easy. The answer is 5. Let's see if you can solve this puzzle. Tell me how many rational numbers are there between 1 upon 5 and 4 upon 5. Are there 2 rational numbers or more? Let's watch this video to find the answer by learning methods to find rational numbers that lie between 2 rational numbers. A rational number is a number that can be expressed in the form p by q, where p and q are integers and q is not equal to 0. For example, 1 by 2 is a rational number. So are 3 by 4, minus 4 by 7 or 243 by 350. If you take any 2 integers, say 1 and 10, it is very clear that there are exactly 8 integers, 2, 3, 4, 5, 6, 7, 8 and 9 between them. However, between 3 and 4, there are no integers. Now, what if you consider 2 rational numbers? Can you find a rational number between 1 by 5 and 4 by 5? We know that 1 by 5 and 4 by 5 lie between 0 and 1. You can clearly see that the rational numbers 2 by 5 and 3 by 5 lie between 1 by 5 and 4 by 5. Now we have seen that there are no integers between 2 consecutive integers. So in the case of rational numbers, is it possible to find another rational number between any 2 rational numbers? Let us consider 2 fractions, 1 by 3 and 1 by 5. For comparing the 2 rational numbers, it is important to convert them to rational numbers with the same denominators. The least common multiple of the denominators 3 and 5 is 15. So, multiply the numerator and denominator of 1 by 3 by 5 to get an equivalent fraction, 5 by 15. Similarly, multiply the numerator and denominator of 1 by 5 by 3 to get an equivalent fraction, 3 by 15. As the denominators are the same, the bigger the numerator, the bigger the number. Which integer comes between 3 and 5? The answer is 4. So 4 by 15 lies between 3 by 15 and 5 by 15. But we have already seen that 3 by 15 is equal to 1 by 5 and 5 by 15 is equal to 1 by 3. That is, the rational number 4 by 15 lies between the rational numbers 1 by 5 and 1 by 3. Now, is 4 by 15 the only rational number between 1 by 5 and 1 by 3? What if we could write the 2 given fractions 1 by 5 and 1 by 3 with a common denominator other than the least common multiple of the 2 denominators? Let us rewrite the fractions 1 by 5 and 1 by 3 with a common denominator of 45. For that, multiply the numerator and denominator of 1 by 5 by 9 to get an equivalent fraction, 9 by 45. Similarly, multiply the numerator and denominator of 1 by 3 by 15 to get an equivalent fraction, 15 by 45. Since the denominators are the same, let's look at the numerator. We know that between 9 and 15, there exist the integers 10, 11, 12, 13 and 14. Hence, it is clear that the rational numbers 10 by 45, 11 by 45, 12 by 45, 13 by 45 and 14 by 45 lie between 9 by 45 and 15 by 45. That is, these 5 rational numbers also lie between 1 by 5 and 1 by 3. In this way, it is possible to find many more rational numbers between any two rational numbers by considering the equivalent fractions of the given rational numbers. Moreover, if we consider any two rational numbers a and b, then the average of the two, a plus b by 2, would be in the middle of the numbers a and b. Now, we can find another rational number between a and b, that is, the average of a and a plus b by 2. And this process can go on and on. So there are infinite rational numbers between any two rational numbers. Find 4 rational numbers between minus 3 by 4 and minus 4 by 7. First, write the two fractions with the same denominator using the least common multiple of the denominators 4 and 7. The least common multiple of the denominators 4 and 7 is 28. Now, multiply the numerator and denominator of minus 3 by 4 by 7 to get an equivalent fraction, minus 21 by 28. Similarly, multiply the numerator and denominator of minus 4 by 7 by 4 to get an equivalent fraction, minus 16 by 28. Comparing the numerators in order to compare the two rational numbers minus 21 by 28 and minus 16 by 28, we have minus 21 less than minus 16. Hence, minus 21 by 28 is less than minus 16 by 28. We know that between minus 21 and minus 16, there exist the integers minus 20, minus 19, minus 18, and minus 17. Hence, the fractions minus 20 by 28, minus 19 by 28, minus 18 by 28, and minus 17 by 28 would lie between minus 21 by 28 and minus 16 by 28. Since we know that minus 21 by 28 is equal to minus 3 by 4 and minus 16 by 28 is equal to minus 4 by 7, we can say that minus 20 by 28, minus 19 by 28, minus 18 by 28, and minus 17 by 28 would also lie between minus 3 by 4 and minus 4 by 7. To summarize, a rational number can be defined as a number that can be expressed in the form p by q, where p and q are integers and q is not equal to 0. We can always find a rational number between any two rational numbers. If a and b are any two rational numbers, then the average of the two lies between a and b. We also learned that we can find infinite rational numbers between any two rational numbers. Now let us continue with our number game. Let us have the same rational numbers 1 upon 5 and 4 upon 5. Can you tell me what the sum of 1 upon 5 and 4 upon 5 is? Or what is the product of 1 upon 5 and 4 upon 5? Or by what number should 1 upon 5 be multiplied to get the product as 1? To learn these operations and properties of rational numbers, keep watching our upcoming videos.
Keep imbibing. We believe in you.